Welcome back to Knowledge Equity Partners. Today, we are opening the playbook on how to build a sovereign AI agent from the ground up. When you hear the phrase sovereign AI, it is easy to picture billion-dollar data centers, hyperscale infrastructure, and government-level budgets. That perception creates a massive problem for elite financial researchers and risk analysts. You hold highly sensitive, proprietary data. Sending those internal memos to public APIs is an absolute non-starter for compliance. But building a massive physical server farm is completely out of scope. The answer to this problem is the Mini Sovereign Stack. This is a lean, highly capable AI architecture that you can run entirely on a single local workstation or a small rented cloud node. It means your team gets complete data lockdown and powerful AI reasoning capabilities without needing an enterprise-scale budget to pull it off. Let's look at the engine room. The absolute baseline of this blueprint is your hardware, and you can start right at your desk. This chart compares your primary hardware options. On the left, local setups using workstation cards like the RTX 4090 or professional Ada cards give you 24 to 48 gigabytes of video memory. On the right, if you prefer a pay-as-you-go model, cloud instances using H100 or B200 chips offer massive scale-out potential. Once the silicon is in place, you need to bring it to life with the right software engine and a model that fits your hardware. We load an open weights model like Nematron 3 Nano directly onto the GPU. We wrap it in vLLM for efficient serving, which outputs a universal OpenAI-compatible REST API, letting internal tools connect instantly. You have just turned off-the-shelf hardware into a fully functioning private AI endpoint. The data goes in, the reasoning comes out, and nothing ever leaves your control. But simply hosting a base model is rarely enough for specialized work. You want an internal analyst, not a generic chatbot. You customize it by feeding in your own proprietary financial memos and risk reports, using a lightweight training process called LoRA, or low-rank adaptation. The model learns the specific language, formatting, and logic of your firm. You then test that newly fine-tuned model against the base version and public frontier APIs. This evaluation loop ensures your internal model is actually hitting your exact accuracy targets. This final architecture piece is a central routing node, a traffic cop for prompts. Sensitive internal data goes straight to your locked-down local Nematron model. Broad, non-sensitive macro questions are pushed outward to public frontier APIs like Claude or ChatGPT. This hybrid routing logic gives you the optimal setup. You secure your most valuable secrets internally while still pulling in the massive reasoning power of external models for general public data tasks. Taking this from a whiteboard sketch to a working tool is entirely manageable for a lean team. Let's map it out. This timeline outlines a 4-phase deployment plan. We start with Phase 0, choosing between a local workstation and a cloud setup, followed by Phase 1, where we deploy that base Nematron model onto the GPU. Next, the team moves into Phase 2 to run the fine-tuning and evaluation loops. Finally, Phase 3 integrates the internal console and the routing logic. Start to finish, you are looking at a 3 to 4 month window with part-time engineering support. For anyone building market intelligence platforms or financial trading systems, the strategic path is clear. You can run high-level analysis on your proprietary data without exposing it to the outside world. By building a mini sovereign stack, you secure total control over your most valuable data while seamlessly tapping into the cutting edge of AI reasoning. If you want to see exactly how to execute each phase of this build, make sure to like, share, and subscribe to Knowledge Equity Partners, and join us for the next episode.